All right, in our next unit, what we're going to do is we're going to solve systems of equations, which we've done before in Algebra 1 and Algebra 2. But we're going to do this with nonlinear systems. So it's not going to be a matter of one answer, infinite many, or no solution. There's a whole lot more categories and possibilities going on. So this is a big key to this unit, nonlinear solutions. Okay? We will use the same three methods we've used in the past. We will be using graphing, substitution, and elimination. So I'm not going to go over the methods of how to do each one as we've never seen them before. When you solve by graphing, you graph each one, you look for when they're going to intersect. So in our Chapter 7 test on conic sections, there was a problem similar to this where we were given two different conic sections asked for the system of to solve the system of equations. Okay, so let's take a look at the one on the left. This is a parabola because only one variable is squared. It is going to open down because it's a negative and it's x squared. The vertex of this is going to be -1 and +2. Both the x and the y are liars in conic sections. So I'm going to go ahead and plot that point, -1, +2. And then we have to use the value p to find our focus. So 4p is in the problem. It is 8. If you write -8, that's fine. So it's p equals 2. We are going to go down 2 from the vertex to find our focus. This is not a point on the graph, but it helps us get the rest of it. So just to remind myself, this cannot be a solution. I'm going to use an x. Now I need to get my last 2 points, and my last 2 points is coming from 2p. So if 1p is 2, then 2 of those would be 4. I'm going to go left and right, 4 units. And then as best as I can draw, I'll make my parabola. The other equation on the right side is going to be an ellipse. Both variables are squared. They have the same sign in front of the x squared and y squared. It's equal to a +1. They have different coefficients. So the center of my ellipse is -1, 0. A is 5. That's going to go up and down. B, to get my covertices, is 4. That's going to go left and right because they're where they're found underneath the x or the y. So I'm going to go mark my center. Again, this is not on the graph, so I'm going to use an x to remind myself this is not a point that's on the graph, so it can't be one of my solutions. I'm going to go up and down 5 to get my vertices, and then I'm going to go left and right 4. And as best as I can, I'm going to draw my ellipse. And I see the points of intersection here. And those points of intersection are at 3, 0 and -5, 0. So those are the solutions to the system of equations. Now, just like graphing and any other time we've done it before with lines, if you want to check your answer, you plug these ordered pairs back into each equation and make sure you get a true statement. In fact, you can do that on any method, not just the graphing method. All right, let's do another example of solve by graphing. This time we're going to take in some stuff from other chapters. So we're going to see things from chapter 2. So any parent function that we did in chapter 2, fair game. Any logarithm or exponential from our chapter 4, our last unit, fair game. Polynomials, fair game. So what we're going to see is what we're going to feel like is this test is going to feel kind of like a graphing final. Anything you've ever graphed is coming back. Lines, vertical, horizontal, slanted, any type of polynomial, any type of parent function from chapter 2, our logs, our exponentials, even our rational functions are fair game. So let's graph this one at a time. So for the top equation, we know that this is going to move right 1 and up 3. So what I'm going to do is I'm going to take the parent function, I'm going to graph that, and then I'm going to slide it. So on our parent function, we normally have 1, 0, and then we have the base, which is 5. So 1, 2, 3, 4, 5, and the exponent would have to be 1. And then we'd have -1 for exponent, that's the y value, and that would give us the reciprocal of the base, 1/5. Then we would have a vertical asymptote. And finally, I'm going to go draw my graph. Now, we know when you're using a graphing calculator and not actually graphing the entire thing because it cannot graph a logarithm all the way. It only graphs part of it. A logarithm shoots down so fast that the graphing calculator can't keep up, and it will not graph it, okay? So let me go ahead and just get this entire graph we have. I'm just going to put it all together. Let me group it. What we're going to do is we're going to take this graph and we're going to move it right 1, up 1, 2, 3. There we go. Try to clean this up just a little bit. So you just use your parent functions and the graphing we've done before. Again, you normally have a point at 1, 2, 3, 4, 5 because that's the base 1, right 1, up 1, 2, 3. So I just want to make sure it's clearly marked. Because those are probably going to be important points when we get to the answer. All right, so our other graph is a cubic, and it's going to go right 6 and up 4. So normally we have the point 0, 0. We're going to go right 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4. Normally we'd have the point at -1, -1. 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4. If you want to, you can think of where that first point where 0, 0 got moved to as a locator point and draw an XY axis. So I'd have a point here. So if I would move out 2 to the right, I would go up 8. 1, 2, 3, 4, 5, 6, 7, 8 because this is a cubic. 1, 2 to the left, down. 1, 2, 3, 4, 5, 6, 7, 8 because it's a cubic. And then as best as you can, draw your graph. And there's our second graph. So all that's left is find the point of intersection, which is right here, which is at 6, 4. And that is the ordered pair that would make both of these true. All right. So the next one says solve the systems of equation by substitution. Well, substitution, normally we think it one variable by itself from one of the equations and plug it into the other. You can do that. But when you get to your homework, and especially on the worksheet, that's going to be a trap that you're going to think, oh, okay, get y by itself or get x by itself. What you really want to try to do is find one term that's in both of those, one variable term that's in both equations, and then go substitute for that, or one expression that you see in both equations. I don't see anything that's the same in this equation, so I've got to rely back on the good old-fashioned get one variable by itself. So I can go ahead and just get x by itself, or I can get y by itself. I'll go ahead and choose to get x by itself in the first equation. So I would just subtract y. And then every place I see an x in the first equation, I'm going to go ahead and replace it with this 2 minus y. So let's just drop it in. So my first equation now becomes 2 minus y squared plus 2 minus y times y plus y squared equals 12. So then after this, I'm going to have to go simplify this down. So I'm going to go square this out. Do not kill a puppy rule. Make sure you get a perfect square trinomial. So that middle term, keep the sign, multiply these together and times by 2. Distribute the y in the second part. The rest I'm going to copy down. Now I see that I have y squareds and y's. So I have a quadratic. So I'm going to set everything on the one side. I'm trying to move it so y squareds are positive. If I take a look, I see this negative y squared and this y squared are canceling each other out. So I'll move everything. So y squared's positive. So I'll move everything to the left. So I have y squared. And then I have minus 2y. And then I have this 4, and I got to take this 12 and send it on over by subtracting 12. So minus 8 equals 0. So I solve by factoring. If I cannot factor, then use the quadratic formula. That will happen several times in your homework, the worksheet, or the test. So you're expected that anytime you're given a quadratic, you should be able to solve it. So when I finish this, I get what? Y equals 4 or y equals negative 2. Now I need to solve for x. So I'm going to go back to where I already have x by itself. I'm going to plug these numbers in. So x is 2 minus y. And that's going to help me get the x value here. So I got x equals 2 minus 4. So x is negative 2. Be careful. Put x first, then y second. Sometimes you solve for y first, sometimes you solve for x first, but make sure ordered pairs go alphabetically. And then in the second solution, I have x equals 2 minus negative 2. So x equals 4. So x was 4 when y was negative 2. So in this problem, what we have is a line and some type of like circle. It looks kind of like a circle because it's x squared plus a y squared. It could be an ellipse or a hyperbola, but I'm pretty sure this one's a circle. And that's where they would intersect. So when you do substitution, the old classic way to get one variable by itself applies. We'll see a problem here on the next slide where I'm not going to get x or y by itself. I'll get something else by itself. All right. The next type is solved using elimination method. So what we have here are two conic sections that are kind of rotated at a weird little angle. Not something you would know how to do in graph until you get to math analysis. So if we start seeing graphs on these type of problems, we know you're using software, which means you get a 0 on the problem. You're not doing anything we're teaching, so you won't get credit. So make sure you know the elimination method on this. By the way, if you don't use the method that you are told to use on the test, you will only receive 1 out of the 10 points for having 100% of all the answers correct, written as ordered pairs, written the correct way. So the chance of you getting a 0 on the problem is very, very high if you use the wrong method. So make sure you know elimination. So what I see in this problem is I see there's x squareds, there's xy's, and there's y squareds. So I need to be able to get rid of those, all the x's or all the y's together. So what I'm looking to eliminate is something I can eliminate both x's or both y's. If I times the bottom by negative 2, I can get rid of the x squared, but I can't get rid of the x's. But if I times the bottom by negative 1, I can get rid of my y squareds, and I can get rid of my xy's. So when I see something that looks the same, with the same coefficients in the problem, that's what I'm going to attack. That's what I'm going to go eliminate. So I have what? 2x squared plus xy plus y squared equals 8. And the second equation, I'm going to times by negative 1. And I'm going to get negative x squared minus xy minus y squared equals negative 4. Make sure you times both sides of the equation. What we want is the same number, different signs in front of these variables with all the y's or all the x's. So unlike Algebra 1, you can't just eliminate whatever you want. You have to eliminate what's available to eliminate, which is possible. So I get x squared, those are zeros, equals 4. So I can square root each side if you remember to use a plus or minus with your square root. Or I could set equal to 0 and factor this quadratic, which the factoring tends to get me both answers. Yes, you can go here if you remember square root, use a plus or minus. Now, I'm not finished with this problem. I need to go find the y coordinates. So let me take the easier equation to work with. I think it'll be x squared plus xy plus y squared equals 4, a little bit smaller coefficients. And I'm going to go find the y coordinates. There might be more than one for each one of these. So let me replace every x with a 2. So 2 squared plus 2 times y plus y squared equals 4. Well, this is a quadratic. Let me put everything to the left side and make the y squared positive. And when I subtract this 4 over, it's going to give me a 0. So now I can factor and get y times y plus 2. I get y equals 0 and y equals negative 2. So my ordered pairs, x was 2, y was 0, x was 2, y was negative 2. Now let me go find the other one. So let me plug negative 2 in there. So in the second equation, that's what I'm using. If I plug in negative 2 and square, I get positive 4. Then negative 2 times y, y squared, and 4. So y squared minus 2y equals 0. So factor. Solve by setting each factor equal to 0. And then I get y equals 2. Write your ordered pairs. So negative 2, 0. And then negative 2, 2. So if you had a circle and ellipse and you wanted to draw both of them, they could intersect 4 times. That's what's happening in this situation. So you could get a lot of points in this intersection. You could get no intersections. You could have an ellipse that looks like this. You could have a circle in here and have no points of intersection. So when you get to your worksheet, I believe there's 3 problems that are going to have no real solutions. All right. This last problem gives you your choice. You can either do substitution or elimination. I'm going to work it both ways. Let me go ahead and start with the substitution method. Now, in substitution, a lot of people are like, oh, get x by itself. It's really easy to get it by itself. But if you do that, you're going to have a y squared, and then you're going to have to square that. And you're going to end up with a quadratic in disguise to solve. And there's going to be a chance you're going to get a bunch of extraneous solutions when you work with it. That when you go plug it back in, the other variable will be imaginary. That's a possibility, by the way, in any problem. So what I'm going to look for is something I see as variables that are the same. It's the y squareds. So if I wanted to do elimination method, I would times the top one by 2. So if I want to do substitution, I'm going to take one of the equations and get a y squared by itself. So for the substitution method, I'm going to take the first equation, and I'm going to subtract x squared from both sides. Then I'm going to go to the second equation and replace every y squared with 2 minus x squared. So I'm going to take this right here and put it in for this y squared. Let me copy down the rest of the equation. So I see that I'm going to deal with a quadratic, so I'll get it set equal to 0 and solve. So I'm going to go distribute the negative 2. Add 1 to each side. And this is the equation I'm going to solve. So I'm looking for things that multiply to be negative 6, add up to be 1. So the bigger one's a negative or positive. The smaller one's going to be a negative because they had to be a positive. Have to be 1 apart and multiply to be 6. So negative 2, positive 3. So let me just do the down under method or flyby or whatever you want to call it. So I'm going to use these numbers as the second number. You're going to put a 2x in front of both ones. And then you're going to divide each one of these by their greatest common factors. You can do MARF, where you rewrite factor by grouping. Bottoms up. I call this one the down under method. There's a lot of different names. You've learned a lot of different things. I don't care. If you want to use quadratic formula or complete the square, that would work as well. That's your choice. So I'm getting x is 1. or x is negative 3/2. So now what I need to do is I need to go find the y coordinate. Now I could go back here and try to find it, and that's perfectly fine, or I could go right here. I see that x is not a square. That might be a little bit more restrictive. So that's sometimes a way to go find it, but I'm looking for y. It really doesn't matter. So let me go back to where I got from the very first step right here when we got y squared by itself. So y squared, that is equal to 2 minus x squared. So I get what? Y squared equals 2 minus 1, or y squared equals 1. So y equals 1 or negative 1. So x was 1, y is 1, x is 1, y is negative 1. Be careful about trying to put plus or minus in ordered pairs, because if you do it wrong, you might get too many points that you don't need. Sometimes it's okay, sometimes it's not. In this case, it would be okay if you did 1 comma plus or minus y. Now let me take a look at the second one. Get y squared equals 2 minus 9/4. That's 9/4, or $2.25 if you want to think about money. That's less than 0. A squared number, a real squared number, cannot be less than 0. This is not real. If I was taking pre-calculus in college, they would expect me to find those values. But in college algebra, we're not going to in our nonlinear system. So it only has 2 real solutions. That was the substitution method. Let me redo this problem using elimination. So elimination method, what I'm trying to do is find something that I can just get rid of by adding. Well, if I times the top one by 2, I should be able to get rid of these y squareds or y's. Now, the one little warning I have on doing the elimination method here is do not add unlike terms. So do not add the x squared term and the x together. They are unlike. They're separate terms. So I have 2x squared, and that's going to be added to x. We're going to see that these y squared terms go away. I get 3. At this point in time, I'm done working out this problem because I've done all the rest of it over here. So if I subtract the 3 over, it works out the exact same way. So it's really not a whole lot different amount of work, but that's the way we can make a Form A and Form B. And if we see you doing elimination method, when somebody's asked to do substitution method, again, you only get 1 point for having the 100% correct right answer. Other than that, you're going to get a 0 if you use the wrong method. Make sure you read instructions and do the correct method. All right, our last problem here is just an application and something we'll see in the bookwork, your assignment for today. A rectangle has a perimeter of 64 feet. So don't forget the formula for perimeter. It's 2 length plus 2 width. And an area of 240 square feet. So length times width is what area is equal to. Okay? If you want to write area equals length times width. So what we have here is a problem is asking us to find both dimensions. Make sure you write down 2 answers. And here's something you want to consider. It's going to look like you're going to get 2 possibilities when you do this, but you might have a rectangle that looks like this, or somebody might rotate it this way. They're congruent, so they have the same perimeter, same area. I just don't know which one's the length and which one's the width. So don't let that mess with you. Okay. All right. So let's go back to solving this problem with the information we're given. So our first equation, the perimeter 2 length plus 2 width is 64. Now I could go and take this and I can make it easier to work with by putting what we call true standard form, writing equation lines. That's going way back to like the first week of class. I can divide every term by 2 to make it a little bit easier calculations. And then my second one would be length times width equals 64. So I have my 2 equations, and I have 2 variables. If you got 2 variables, you must come up with 2 equations. If you have 3 variables, you must come up with 3 equations. We're going to see that. Or some of you saw that earlier this year. Some of you are going to see it a little bit later, depending on who your teacher was. Okay? So what we're going to do now is we're going to get one variable by itself and put it in the other equation. I don't see any term that's the same. I see an LW term, an L term, a W term. I really don't want fractions, so I'm going to have to go get one of these by itself. So how about I make your width equal to 32 minus L. Subtract the L from each side. So I'm going to go take this and replace this W right here with it. So let me rewrite my second equation as L times 32 minus L equals 64. So I have 32L minus L squared equals 64. I'm going to move everything so L squared is positive. So let me move everything to the right. And then I'm going to solve by factoring if I can. So if I can think of 2 numbers who have the same sign that multiply to be 64 and add up to be negative 32, I would factor. If I can't factor it, or I don't see those numbers, if I get stuck for more than 30 seconds, the technique I'm going to try is I'm going to use quadratic formula. So if you can't think of this, then let's go ahead and do quadratic formula. So our length is 32 plus or minus the square root of. Now we're going to do the discriminant. Okay, just to keep my writing down a little bit, I'm going to take this discriminant, I'm going to do it off to the side. So that is negative 32 squared minus 4 times 1 times 64. I'm just going to grab my calculator and put it in there and see what I come up with. And I have 768. Okay, so that's the number I'm going to put in the square root. Now, if this was a nice, neat, perfect square, it means I could have factored. But if we take the square root of this, it's going to be 27.7. So it's not. So what I'm going to do is I'm going to just go put this all over 2 times a. So all over 2. So my length, if I take this in the calculator and put this in there, and do the 32 plus the square root of 768 and put that all over 2, I come up with 29.856. Let's just go 3 decimal places. Or I get, if I just do it with a minus, I get 2.1435. Now I need to go find the width for each one of these. So don't forget how we got rid of our first variable. We said that the width was 32 minus L from earlier. So I'm just going to bring that down here as a little reminder. And now I'm going to subtract these answers from 32. So I'm just going to use the numbers that were stored in my calculator and calculate them. And I'm getting something kind of interesting here. So you can round or truncate. Truncate just means erase the 4th decimal. That's okay. And when I subtract these, I'm noticing I'm getting the other possibility for the length. Remember, we can rotate this rectangle 90 degrees and it would give us another rectangle with the exact same dimensions. Okay, just which one do you call length and which one do you call width? If you rather call them base and height, you can do that. So last thing I have to do to answer my problem is make sure I label it properly. And they said feet. That's the dimension or the unit of measurements. So one dimension is 2.143 feet. The other dimension is 29.856 feet. So you can go to decimals and go to 3 decimal places. If you really, really wanted to, you could try to put this in simplified radical notation. Which I'm looking at right now. Okay, so this right here is 256 times 3. So if you really want to put in simplified radical notation, then it would be what, 16 square roots of 3 over 2, and 32 over 2, plus or minus. So 16 plus or minus 8 square roots of 3. Those would have been, this would have been the plus. And this one over here would have been the minus for L. And when we subtract them, we realize we're going to get the other one. So if that's how you want to do this in simplified radical notation, that's the exact answer. We could live with either one of these answers. All right, that's the end of the notes. For the plan, our day 1 assignment is going to be the book. Our day 2 assignment is going to be the worksheet. And then on day 3, we're going to take a quiz on GoFormative.